everybody, welcome back. I'm Amy Jensen. Today we're going to finish reviewing graphing rational functions, and we're going to do some problems that you might see on an upcoming test or quiz like these. So grab a pencil and some paper and let's get started. And for this video, you may want to pause the video, try the problems, and then test yourself as if you're taking the test yourself. So recall you need to be able to identify all these characteristics for any rational function. And we discussed these in detail in a prior video, but x-intercepts, remember you want to give your answer as a coordinate point. If you are asked for the 0, that is when you just give the x value. Y-intercept, obviously you give that as a coordinate point. If there's a hole in the function, that's a coordinate point. A vertical asymptote, horizontal asymptote, and slant asymptote will always need to be given as an equation, meaning there has to be an equal sign there. So vertical asymptote is x equals something, horizontal asymptote would be y equals something, and a slant asymptote for our problems will be the equation of a line, if there is one. Domain and range, you always use interval notation when you write your answer, and usually the domain will be negative infinity to whatever the x value of your vertical asymptote is. So you're going to jump over that vertical asymptote and then, or more, there might be more than one vertical asymptote, so be careful there. And then same with the range. So the range, you're probably only going to be asked to identify the range if it's a pretty simple function or maybe if there's a hole in the function. Otherwise, domain is definitely fair game, but be careful with the range because that can be kind of confusing, especially if your function crosses the horizontal asymptote, in which case that value of y would be a valid value of y. So once you've identified your characteristics, we need to graph the function. Always show the asymptotes, intercepts, and holes every time you graph. Okay, so let's do some of these problems. We will also cover writing an equation of a rational function given the characteristics of the function, as well as identifying the transformations from the parent function 1 over x. So here we go. So again, you might want to pause this right now and come back and check your answers. So for this function, this is a little bit challenging. We need to identify the x-intercepts and all the characteristics. So first, we always factor. And so in the numerator here, we can factor out an x, and then we can factor that even further. Let's see, x plus 3, x minus 2. Okay, and then in the denominator, let's see, that's going to factor to x plus 1 and x minus 2. Aha, x minus 2. We see a common factor there, so let's write it this way so we can just cross those out right on top of each other. So x minus 2, that is a situation where the graph will have a hole in the function at x equals 2 because that's the factor that we've crossed out. And then we're left with our simplified function of x times x plus 3 all over x plus 1. So now let's identify these characteristics. So starting with the x-intercept, recall we set the numerator equal to 0 and solve for x. So don't forget about that x hanging off the end there. We have to set that equal to 0 also. So we get two x-intercepts here, negative 3, 0, and 0, 0. Now if you were asked for the 0, that is when you just give the x value of your x-intercept. And then the y-intercept, the easiest way is probably to go back to the original function before we simplified it. or you can plug the 0 in factored form here. Either way, you're going to get 0 over 1. And so our y-intercept then would just be 0, 0. So if we had just covered up the x's in the original equation with our finger, you could easily see that your answer would just be 0 for your y-intercept. So again, we're going to write that as a coordinate point as 0, 0. And now let's go ahead and write the coordinate point for the whole. So recall the whole happened when we crossed out that common factor of x minus 2. So we set x minus 2 equal to 0. And of course that's x equals 2. And then we're going to plug in 2 into the simplified function here to get the y value of the whole. So let's see, 2 times 5 all over 3, so we get 10 thirds. So the coordinate point then would be 2, 10 thirds, which when we graph it, that will be 3 1/3. A little bit easier to think of it that way. So moving on, let's find the vertical asymptote. Recall that's where the denominator equals 0. So that would occur at x equals -1, where the function is undefined. And then we will find the equation of the horizontal asymptote, if there is one. So remember, you want to look at the values of your exponents, and the value of the exponent on the top is bigger than the exponent on the bottom. So we do not have a horizontal asymptote in this case, which means that we need to write none for our answer, and then we need to check to see what the equation of the slant asymptote is. So remember, with the slant asymptote, we need to use either long division or synthetic division and divide the numerator by the denominator. So we want to go ahead and use the simplified function in this case. So if we distribute that x, we get x squared plus 3x divided by x plus 1. So x goes into x squared x times. So we'll multiply that. And then remember, I'm subtracting those. So x squared minus x squared, that'll cancel out. 3x minus x, I get 2x. And then x goes into 2x 2 times. And remember, once I've multiplied 2 times x, those will cancel out. That remainder doesn't matter. So all I really care about is that x plus 2, and that will become the equation of the line that is my slant asymptote in this case. And then finally, let's go ahead and write the domain. So remember, the domain, we can look at the vertical asymptotes, and then we also have to look at the x-coordinate of the whole that we have in this graph. So don't forget that x-coordinate in the whole. So remember, you want to go left to right, so let's write -1 first. So -infinity to -1, union, -1 to 2, union to infinity, and that's our domain. So now let's go ahead and graph this function, and I think it's always easiest to just start off graphing by identifying the vertical asymptote on the graph and then the slant asymptote. So vertical asymptote is the red hashed line, and then the slant asymptote, start with your y-intercept. We just have a slope of 1, and we're going to show that as another dashed line here. So you need to show those pretty clearly on your graph. And now I can go ahead and also plot the coordinate for the whole. So that occurs at the point where x equals 2 and y is 3 1/3. So let's get that. We'll draw that as an open circle on the graph, right about here, really close to that slant asymptote, but obviously doesn't really touch it. The slant asymptote value there would be 4. And then I want to make sure and draw in the x-intercepts and the y-intercepts, and I need to just kind of test a few points to see where the graph is going to go. So let's test a point to the left of the vertical asymptote. Let's try -2. So I'm going to plug in -2 into that simplified function. And I'm going to get -2 over -1, so that's +2. So I can kind of plot a point there. And then let's see, and I know that my x-intercepts occur at -3, 0, and 0, 0, so I want to go ahead and put those on my graph. And now let's just kind of go through and check off, do we have everything we need to show? Looks pretty good. And if you want to, you can plot another point, say further left, like -10. That's always, 10's always an easy number to use. So if we plug that in here, let's see, we're going to get 70 divided by -9, which is a big negative number. So close to, it's almost like if we did 70 divided by 10, you could figure it's about 7. It's going to be a little bit more than 7, and in fact it's about 7.8. So if we wanted to show that on the graph, we just know that it's going to be really close to that slant asymptote further out. And so now I can just connect the dots, hug the asymptotes that I've drawn here, and then go to the other side of the vertical asymptote. Make sure you leave that hole showing as an open circle. Don't go right through it. And there we have our graph. So remember, with these rational functions, you'll always have 2 distinct parts of your graph, at least 2 distinct parts, if not more than that. So that's a quick review. If you need more reviews of these graphs, you can go back to the prior videos that we've done, and we've worked through several other problems like these. So let's move on to a different type of problem. In this case, we're asked to write an equation given the characteristics of the function. So for these problems, remember, we want to work backwards. So we're given the x-intercepts, the vertical asymptote, and the horizontal asymptote in this case. So the x-intercept, remember, that's where the numerator equals 0. So we can just write those in factored form, and we would get 5 and 1 with the factors x minus 5 and x minus 1. And we'll kind of start our little fraction down here and go ahead and write those factors there. Okay, the vertical asymptote, remember, that's where the denominator equals -1. So our factor would be x plus 1. And we can go ahead and write that in the denominator of our function. And then it tells us we have a horizontal asymptote. There's no horizontal asymptote. So remember, that's where we need to have the exponent must be bigger on the top in the numerator than on the bottom. And the way our function's written right now, if we were to FOIL that together, we would get an exponent of x squared. So we're all set. And then just remember to write your answer as an equation. So f of x or y equals. And then depending on what your teacher requires, you may be required to multiply that out and give your answer in simplest form, meaning no parentheses. But unless you're told to do that, leave your answer in factored form, because there's a lot less chance that you're going to make a silly mistake right at the end multiplying things out. So just leave it like that. Here's another one. So write the equation given these characteristics. Okay, in this case, we're given a hole in the function. So we know we have to have two factors that cancel out when x equals 5. So remember that has to be x minus 5. It'll be the opposite sign there. And then we're going to come back and check on that 1 value for the y value in just a minute. So then for the vertical asymptote, remember the whole will cancel out, so I'm not going to use that x minus 5 for the vertical asymptote. I need a different x to give me x equals 0. And that's how I get that vertical asymptote. And then the horizontal asymptote, so if y equals 0, remember the exponent has to be smaller in the numerator than in the denominator. And right now with my function, that's the case. That works. So everything looks good, except I still need to come back and check on the y value of that whole coordinate point. So 5, 1. So if I plug in x equals 5 into this function that I'm writing, I need to get y equals 1. And so sometimes we need to multiply another constant by the function or do something else to get it to work. So if I plug in x equals 5 the way it is now, I would get 1 over x, which is just 1 over 5, 1/5. Well, that's not 1. So what would I need to do to this function to get 1 instead of 1/5? In other words, what number do I need to multiply by 1/5 to get 1? 5. So if I put a 5 in the front of that factor in the numerator, now when I plug in 5 for the x value of the whole, it will simplify to 1, and it all works. So again, I need to make sure and write my answer as an equation. And so I can write f of x equals 5 times x minus 5 all over x times x minus 5. And unless you're told otherwise, remember, just leave it like this in factored form. And this isn't the only correct answer. Another correct answer that works and meets all the criteria above would be this one. Okay, so the third type of problem we might see is to identify the transformation from what we call our parent function, the function 1 over x. And remember the transformations that can happen. We can have stretch or shrink. It could be reflected over the x-axis. We could have a vertical shift or horizontal shift. Now these questions will only refer to an exponent of 1 in the denominator. In other words, it has to be the function 1 over x, and then we're transforming that. So the first thing we want to do is factor out the 3 in the denominator. And then we can look at the 5/3, which is actually the constant or the a value in our formula, if you remember that from our first video that we did. And 5/3 is greater than 1, so don't get confused and think, oh, it's a fraction, it's shrinking. But in this case, 5/3 is greater than 1, so it's stretched by a factor of 5/3. And then x minus 3, remember the graph is moving in the opposite direction with the x's in parentheses there, so it's shifted right 3 units. Okay, let's try one more of these, since we haven't done them in a while. So try this one. Notice it's not in the order that we're used to seeing it in. So let's rewrite that as 1 over negative x plus 3. what you might want to do when you have a negative in the denominator is factor out a negative, which means you're going to put the negative at the top of your fraction in the numerator and change the signs for both terms in the denominator. So since we have a -1, that means the graph is reflected over the x-axis, and x minus 3, again, it's shifted right 3 units. Okay, this is a little bit of a challenge. There's 2 challenge problems here. So pause the video, see if you can do these. So you want to state the equation of the horizontal asymptote. Well, what makes this complicated or a little bit difficult is that first we need to find the least common denominator. So this is kind of pulling back some material that we've done before, but that wasn't necessarily covered in this unit. But you need to know we need to make this expression all into one fraction. So we identify the least common denominator. And then let's go ahead and I'm going to multiply my terms together so that I can combine everything. And then I'm going to write it all over that one common denominator. So remember, I'm just looking for the equation of the horizontal asymptote of the function. So I need to just look at the highest exponent in both the numerator and the denominator. So if I FOIL out the denominator, I'll have x squared in the top and in the bottom. So if I look at the constants there, since x squared and x squared are the same, that gives me the horizontal asymptote, that is y equal to 1/3. So it's really not hard. You just have to remember to get that common denominator and multiply everything out. Last challenge problem. This is a good one. So does the graph of the function cross the horizontal asymptote? Remember, it can cross the horizontal asymptote. It cannot cross a vertical asymptote, but it could cross a horizontal asymptote. So how do we do this? Well, we know the horizontal asymptote occurs at y equals 3. So we need to set our function equal to 3. And then we just solve for x. And if we get something that works, that's a true equation, then we know the graph does cross the horizontal asymptote. If we get something that doesn't work, such as like 2 equals -6 or something that's not true, then the graph would not cross the horizontal asymptote. So let's see. So if I solve for x, and I'm going to add 4 to the other side, so I'm going to get x equals 10. So in fact, this graph will cross the horizontal asymptote at y equals 3 at the value where x equals 10. So I already know the y-coordinate of that point because I set the equation equal to 3, which is the equation of the horizontal asymptote. So the coordinate point is going to be 10, 3. But let's just check it to be sure it all works out. So if I plug in 10 for x back into my equation, let's see what happens. So if I simplify all this, sure enough, this equals 3, which is the value at the horizontal asymptote. So yes, the graph will cross the horizontal asymptote at the point 10, 3. So this was a quick review of rational functions. If you need more help, go back and watch the first 2 videos in this series. You can do it. It just takes some practice and working a lot of problems. Thanks so much for watching. Have a great day.